Okay, hello everybody. Ooh, sorry, that was a little bit of a delay. Today we're going to be graphing inequalities of quadratics. So before we begin, here's a picture of a cat and a pumpkin. Isn't it cute? Okay, so that's that. Now I need to graph these. When I graph these, I'm going to take them apart and graph one at a time. And when I graph them, I'm going to pretend that this were y equals, just like we did in section 1 of chapter 4. So the very first thing I need to do is I need to take a look at this. When I graph, I'm not picking random points anymore. I actually know where to start. I need to start with the center of this parabola. The center is what we call the axis of symmetry. It's a line where the parabola is symmetrical. That equation is negative b over 2a. This right here is only true when your quadratic is in standard form, ax squared bx plus c. So if it's negative b over 2a, well, my b value is 4, so it's going to be negative 4 over 2 times a over negative 2. So this means that x is equal to negative 4 divided by negative 2, or x is 2. So right off the bat, I know that my center, or my axis of symmetry, is going to be this line, x is 2. Now my vertex is also on this line. So my x-coordinate for my vertex is going to be this 2. Now in order to find out where my y value is, I need to take this x value and plug it into here. So y is going to equal negative 2 squared plus 4 times 2 minus 4. So y equals negative 4. Remember, this is not in parentheses. You square the 2 first, you square the x first, and then you multiply it by negative 1. So it's a negative 4 plus 8 minus 4. Well, negative 4 plus 8 is is positive 4. Minus 4 is 0. So right here, that's going to be where my vertex is. Now I can just pick some points. So I'll tell you what, why don't we pick negative 1? Okay, fine. Plug in negative 1 for here. Well, negative 1 squared is positive 1. With this negative out front, it's negative 1. Plus 4 times negative 1, well, that's negative 4. So we got a negative 1 plus a negative 4 is negative 5. Minus 4. You know what? I'm confusing myself. So why don't we write this out? So for x equals negative 1, we got y equals negative 1 squared plus 4 times negative 1. Oh, sorry. That's why I'm confusing myself. We're looking at positive 1. Oh, been a long day, I tell you. All right, so if x equals positive 1, I have negative 1 squared plus 4 times 1 minus 4. This is negative 1 plus 4 minus 4. Y equals negative 1. Down here. Now, I don't even need to do any more math because this is the y-axis. This is where x is 0. X is 0 on the y-axis. I know just by looking at this, my y-intercept is negative 4. So 1, 2, 3, 4, right there. I also know, since this is my axis of symmetry, if I go the same distance on the other side, I can graph the same y values. So those are my points for my parabola. Now this is y is less than, so that means that this is going to be a solid line. Less than or equal to, I mean. Whenever you say or equal to, solid line, just like this. All right, so now I can take a look at my second quadratic here. We'll make this the blue guy. Okie dokie. So, just like before, I need to find my axis of symmetry. X equals negative b over 2a. Okay, well, x is going to be negative b. Here, b is 1. So it's negative 1 over 2 times a. Well, a is 2. So it's going to be 4. Yay, fractions! X is negative 1/4. We'll say that's about there. That's going to be my axis of symmetry. To find my vertex, all I need to do is plug this back into the original equation. So I'll say that y is going to be equal to 2 times negative 1/4 squared plus a negative 1/4, or just minus negative, or minus 1/4, minus 8. Well, 1 over 4 times 1 over 4 is going to give me positive 1/16 minus 1/4 minus 8. Well, 2 times 1/16 is going to give me 1/8 minus 2/4, or 1/4, which is the same as 2/8, minus 64/8. Common denominator, right? So now I can say that y is going to be equal to 1 minus 2, which is negative 1, minus 64 is a negative 65/8. So y is going to be equal to roughly about negative 8 and 1/8. So then down here, 1, 2, 3, 4, 5, 6, 7, 8. And an additional 1/8. Can't really, there we go. There's my vertex right there. Now I can plot some points. Well, look, I know that y, or the y-intercept is going to be negative 8 because it's my c value. So I can make this point negative 8. Now be careful here because my axis of symmetry is negative 1/4. That means that I went 1/4 to the right. So if I go 1/4 to the left at x is equal to negative 1/2, that's also going to be an 8. Because there's a fraction here and plugging it in and trying to count may be a little bit complicated, it's okay if we stick to whole numbers for the rest. Just as long as we're aware that our points aren't exactly going to be symmetrical. Here's what I mean. If I look at x is equal to 1, well, that's 2 plus 3, which is, 2 plus 1, which is 3, minus 8 is negative 5. 1, 2, 3, 4, 5. There. Don't think that on this other side it's also going to be negative 5. If I plug in negative 1, that's going to give me 2 minus 1, which is 1, minus 8 is going to be negative 7. 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5, 6, 7. Okay? Doesn't quite look symmetrical because I'm not going equidistant on either side of the axis of symmetry. That's okay, and I can graph that now. Sorry, I did that wrong. I got ahead of myself. What did I do wrong? This is y is less than. There is no equal to. So this is going to be a dotted parabola. Now, I need to shade. This is going to be y is less than this parabola. The blue parabola, right? Y is less than. Y is also less than the red parabola, meaning that less is down, positive is up. So I'm going to be below both of these. So where I'm below both of these is in this area. Okay? That would be my solution for this graph. So I hope you were able to follow along. Sorry, it got a little confusing, and sorry I did make a couple of mistakes there, but I did catch them. The important part of doing this and graphing is to take each one apart, find the axis of symmetries. With those x values, find the y value for the vertex, and then pick some points. Plot, have some fun, and shade. Remember, which I almost did not remember, when y is strictly less than, it's going to be a dotted line. When y is less than or equal to, or greater than or equal to, it's going to be a solid line. Make sure you're aware of that and get some more practice. As always, if you have any questions, send me an email, talk to me after class. See you guys.